All right. Yes, yes. The person who made this worksheet really went all out with the top, that top little. Really? Oh, but she didn't. But she didn't make them. It was Gina Wilson. So don't be scarred. Just be like, Gina, you make some good looking notes, and lots of teachers buy them. Don't cry. Don't cry. They're good looking notes. Look at these fonts. Look at these fonts. These these are very aesthetically pleasing. They look nice. They look nice. Okay. Um this day of learning is not terrible. This is a pretty nice low key day. So don't take don't take previous scarring into today's lesson, okay? You'll be fine. All right. So today, if you look over at the board, we're learning what congruency statements are, and we're learning if there's a way that we have to write them. And the answer is yes, there is a way that we have to write them, and yes, order is important, okay? This is one of these lessons where, you know how math people are a little bit peculiar about things, you know? They like things to be done a certain way, and precision matters. This is the intro to say that precision matters for the rest of the unit, and today is the day where we are showing, like, just how precise you have to be in how you write things. And it's actually not hard, but we're going to spend a day on it just to be like, okay, I can actually be this precise and it's not too bad. Okay? Make sense? Okay. So congruent triangles. Triangles are congruent when they have the same shape and size. Oh, we've heard that before. Shape and size. Same shape, same size. Look at Miss Rice crossing her Z so it doesn't look like there's a 2 in the middle of that word. How very math teachery of her. This means that all the corresponding parts, all the angles, and all the sides, so all the corresponding parts of the triangle are congruent. So all the angles are equal in measure, all the sides are equal in measure. When triangles are congruent, we can write a congruency statement. So we're answering the first question on the board. What is a congruency statement? This is it. Triangle ABC is congruent to triangle DEF. Are you guys listening? Are you listening? I'm impressed because I can't listen and talk at the same time, but you, my friend, are a good multitasker. That was sarcasm. That was sarcasm. Right. Triangle ABC is congruent to triangle DEF. And I want you to notice these markings that they have. So notice that even though these triangles are not oriented the same, you can see that like they're kind of like flipped around and like twisted and stuff. Angle A is written first. Angle D is written first. In a congruency statement, you guys see that? A and D, they're written first. So those are the ones that are congruent. B is written second. E is written second. Those are the ones that are congruent. C is written third, F is written third, those are the ones that are congruent. So this is the part where math teachers are peculiar and we're being really precise. The order matters. The one that's written first has to be congruent to the one that's written first. You can't just write them out of order and call it good, okay? There is no, we're laid back, we're type B personality, we're go with the flow. Math teachers are not go with the flow. They have to be perfectly in order. Does that make sense? Okay, because the reason we do that is you don't always have a picture. So if you take away the picture, you could give somebody this congruency statement. They could draw their own picture, and they would know exactly which angle goes with which. Does that make sense? Okay, and then you could say, oh, the line between angle A and angle B is the same as the line that connects D and E. You can do the same thing with the sides by looking at what line is between the different angles, okay? And they went ahead and they drew those two. All right. So the next thing we have CPCTC. Has anyone heard of that? People who do a lot of geometry love it. Love it. And nobody says the words, everybody says CPCTC, and they say it fast like that. CPCTC. If you've done any geometry, it's very satisfying. What does it stand for? Corresponding. Corresponding parts of congruent triangles are congruent. Remember how we did the proofs yesterday? We're going to do so many more proofs this unit. Don't worry, they're going to be fun. And once we get to the point where we can say, like, yep, this triangle and this triangle are congruent, once you can say two triangles are congruent, you get to say, because they're congruent, everything is the same. This angle is the same as this angle is the same as this angle is the same as this, the sides are the same, the sides are the same, the sides are the same. That's what CPCTC says. Is that once you can say the triangles are the same, then you can say everything's the same. And it is a shorthand way of saying that, so you don't have to spell it out for somebody. Does that make sense? So you'd be like, basically, you're like, the triangles are the same, everything's the same, CPCTC. Does that make sense? We like to be a little bit lazy, and so we come up with like shortcuts. And this is it, CPCTC. We love it, we're gonna use it. We're gonna spend a whole day on CPCTC. Everybody try saying it, it's satisfying. No, say it faster, say it like a bit. Isn't that satisfying? It's kind of nice. Okay, so I will give you 100%, I will give you 100% on our test if you name your first child CPCTC. Get back to me. All right. Next problem. It's a joke because you can't have your first child by the time. Okay. Don't try though. Don't try though. I'm not condoning. Okay. Don't tell your parents. I'm gonna stop. I need to stop recording. Yeah. Don't do it. Don't do it now. I'm not condoning. Okay. We're moving on. Okay. So this says. Yeah. Do not take that back to your parents. Okay. Now, without a picture, list all of the congruent angles and all of the congruent sides. Okay. So we're going to say we're comparing angle J, angle K, angle L. So I'm going to write angle J, angle K, angle L, and we're going to say what it is congruent to. Okay, which angle is J the same as? P. Angle P. What is K the same as? Q. What is L the same as? R. It's almost like you guys have done this before. Oh. LJ, LK, LL. No, that's how I write angle. Now, if you are a fancy schmancy angle writer, you can do angle, 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 angle. Yeah, I don't do that because I'm lazy. So... Isn't what? What? So, okay, so you have you have a good point. When you first learned how to write your letters, you had your elementary teachers give you like the dotted line letters, and they all looked very uniform, right? And then as you started writing your letters, you made them your own, right? Now, if we compared how we all write the alphabet, are they very similar? But can we read them? So is there a correct way to write an angle sign? Yes, but is everybody going to have like their own handwriting version of it? Yes. So when you've done a lot of math, you're going to recognize it based on the context. You're going to be like, oh, that's angle P, even though mine looks a little bit more like an L. It's the same thing as like, technically a pi sign looks like this. Almost all math people I know write that. Why? Because it's faster. Does that make sense? So a lot of people, even though there's like a certain way to write cursive versus what's non-cursive? Print. A lot of people, there's like a particular way to write print. A lot of people do a mixture of cursive and print, and we don't say you're writing that incorrectly. We just say, oh, that's somebody's handwriting. It's the same thing with math symbols. Like you learn how to write the math symbol, but then if it doesn't look exactly like that math symbol, you don't say they're drawing it wrong. You just say, oh, that's their handwriting. Does that make sense? So it's okay if it looks like a less than sign. It's okay if it looks a little bit different than a less than sign. Okay, good question. All right, next one. So the next one is, how do you write the sides with your congruency statement? So my first side is going to be JK. My second side is going to be KL. And then for my third side, I'm going to do JL. Do you guys see how I got all three combinations in there? JK, KL, JL. So to get the three sides that these are congruent to, we're going to have to take a little bit more thought. So JK is congruent to what? PQ. Okay. KL is congruent to what? QR. And can I say that JL is congruent, goodness gracious, can I say JL is congruent to RP? PR, because order matters. Okay? So if I say RP, it's the same letters, but it's the wrong order, and the order matters. Okay? So we're going to be precise. We're always going to be very particular about the order. The order matters. Okay? We're dealing with type A people that are precise. We're going to be very precise when we do this. Okay, now they said write another valid congruency statement. So they want us to say triangle JKL is congruent to triangle PQR, but they want us to do it in a different order. Okay, so I'm going to start you off. I'm going to say triangle K, and I'm going to let you finish it. We're going to start with K, and you have to finish it any way you want to. There are two options for how you can write this. Okay, go ahead and finish it. Start it with a K, and then go ahead and finish it. There are two different ways you can write it. So you're going to write a congruency statement, but you're not going to start with the letter J. You're going to start with the letter K. All right, what letter did you guys put second? L. Okay, so you shouldn't have put Q second. Okay, so K would be L, then J is congruent to what? Q, R, P. You can't mix letters from two different triangles. Okay. Okay, but we understand now, right? Okay, so that's one option. The other option would have been KJL, and what would that have been congruent to? Triangle QPR. Okay, so two different ways to write your congruency statement, both of them starting with letter K. Okay. All right, I'm going to give you a second, and I'm going to let you do number 2. So write your angles, write your sides with all your congruency statements. So last time I did my last one with my letters JL. I went this direction on purpose. This time I did my last letters backwards. And it's fine as long as I'm consistent, because order matters. So for this one, I did JL and PQ. For this one, I decided to mix it up a little, and I did YW and GE. Ooh, no. As long as you are consistent, because order matters. Yeah. If you wanted to be spicy about it, you could do XW, FE, YX, GF. You could mix them all up. It would make it harder to check your answers on the answer keys, but You wouldn't be wrong as long as you're consistent. What letter should we start with for our congruency statement? Y. Not W. Well, we could do W. You can start with X. That's fine. I'm just going to start with Y, so it means your answer is going to be a little different from mine. It looks like an alternate spelling for the name Jeff.
That's what you should name your child.
Jeff. I had a statistics professor in college whose children all had math names of like statistics, vocabulary terms. I'm not kidding.
What were their names?
I don't remember, but she said her children's names, and all of us, we were all like in our 20s. This was my master's. All of us were like, oh no. That's unfortunate, and when your children are grown, you need to apologize to them. No, my child's name is Confidence Intervals. I'm just kidding. It was like something dumb. Yeah, it was bad. All right. Next problem. So, when I'm going to show you guys a trick that I do. This is probably a trick that most math teachers do, but I'm going to show you guys a trick that I do. Are you ready? Are you ready? Jack, are you ready? You looked like you were like, oh, you were looking down. I was going to say, it looked like you like fell asleep, but like old man. It looks like you fell asleep old man style because you were just like, you had your hands folded and you were just like this.
No, I was looking down.
You know how old men like doze off? Yes. It's low-key adorable. Yes. All right. So this says triangle KPM is congruent to triangle AYC. So we're going to put one little marking for K and one little marking for A. So those are the ones that are the same. We're going to put two little markings for P and two little markings for Y. And then for C, we're going to do, for M, we're going to do 3. For C, we're going to do 3. Yeah. You can do the same thing for the lines, but I don't. I'm going to tell you why. Okay, so here's how I do my congruency statements, and here's why I do not do the lines, okay? So when it says K to M, line KM, we don't just need to match the line, we need to match the order of the letters, right? So here's what I do. KM is 1 marking to 3 markings. You guys see that? So in the other triangle, we need to do 1 marking to 3 markings. This is why I don't match the sides, because I don't just need the side, I need the order of the letters. So I'm going to go to the other one, and I'm going to do 1 to 3, which is AC. You guys see how I did that? So if I had a marking, I could say, yeah, the sides match up, but I need to do the order correctly as well. All right, the next one. CY is 3 to 2. So 3 to 2 is MP. PK is 2 to 1. So in the other one, 2 to 1 is YA. All right. Angle Y corresponds with angle what? Angle P. Angle K corresponds with angle A. Okay. Now angle AYC is 1, 2, 3. See that? 1, 2, 3. So we're going to do what? KPM. Angle KPM. All right. Triangle MPK. MPK is 3, 2, 1. Oh, I almost wrote 3, 2, 1. I was going to write 3, 2, 1, and that's not right. CYA. That's an actual acronym in the business world. It's a joke. It's a joke. Okay. YAC. YAC is 213. So what does that correspond to? 213. PKM. Okay. So see how those markings make your life a lot easier? Okay. So that, I don't know if that's a common geometry trick or if that is just like high school Miss Rice came up with that and it made her life easier, so she did that. Oh, I did these backwards. My dad is dyslexic, and sometimes I wonder if I have just little bits of it. What should this one have been? ACY. 132 KMP. Okay. All right, are we good? We good? Okay. Flip the page. Woo, there's so much more. I'm so excited. Okay. So I'm going to do my markings again. STW. So STW. BFN. N has 3, not 2. Okay. So we know the things that go in that order have to be the same. So if S is 67, what is B? Okay. If, F and T, we don't know either of those. Okay. If N is 82, what is W? 82. How can we find the third angle? Okay. So somebody with a calculator, I'm going to let you do the math because I don't feel like it. 31. Okay. Okay. So from 1 to 3 is 9. 1 to 3 is 9. It's not the Pythagorean theorem. Do you know why? It's a specific reason. It's not the Pythagorean theorem for a specific reason. It's not a right triangle. I mean, it was good for you to think of the Pythagorean theorem. It's just in different situations. From 2 to 3 is 14. 2 to 3 is 14. And then from 1 to 2, 1 to 2 is 17. Okay. So I use the same strategy as before to match up every part of the triangles. So I took my congruency statement and I did my 1, 2, and 3 markings. And then based on my markings, I matched up all my angles and I matched up all of my sides. Let's see if I can zoom in. And now that I have all my angles and my sides matched up, I can take those measurements and I can mark them down. Nate, are you sending somebody a message so they know what the measurements are? Isn't that crazy how I knew you were on your phone? You know how I knew? Nobody has their math paper down here and is trying to look at it discreetly. Nobody, absolutely nobody is like, and the answer to that is 5. There's a clock up there, buddy. There's a clock up there for your convenience. You know why it has a clock? I spent $4 at Target. You know why? You know why? Because I was in her room last year and I took the clock with me. All right, let's move on. All right. Yeah. Yeah, it's funny, isn't it? The funnier part of that is, so my first name, my real name is Catherine, but my friends call me Katie. Her sister's name is Katie. So when she first moved in and my name was still on the door, she was coming in every day with a sister named Katie Price, and she was walking in seeing Katie Rice on the door every day. She's like, this is messing with my brain. And I was like, ha ha ha. All right, let's move on. Okay, did you guys notice the difference in how things were labeled? You guys see that? So look on the previous page. See these labels? How do the labels change? It doesn't have a line. So this is the difference in how math people label things when they want numbers. You guys see the difference? So when we're talking about congruence, we put a line over the top. We're saying this line segment is congruent to that line segment. But when we talk about the length of a line, they don't have the line over the top anymore. Ms. Rice, does it really matter? Tell me how math people are. Do you think it matters to them? They're precise. It matters to them. Okay. I will nicely encourage you to do it better next time on homework assignments and on the quiz. But by the time we get to the test, I'm going to ask you to do it correctly. Does that make sense? Okay. All right. So the length of BN is what? 9 what? Centimeters. The length of TW? 14 centimeters. The length of my best friend? 17 centimeters. It said BF. All right, what is the, and then notice the difference between this and the other side. How do you know that it's talking about a measurement versus just talking about the congruence of an angle? It says M, it says measurement. All right, the measurement of W. 82. The measurement of angle B. The measurement of angle F. 31. Well, that was so fun. Okay, let's move on. All right, the next one, angle G and angle X are the same. Angle H and angle Y. Angle J and angle Z. What other information did they give us about this picture? Yes. It's isosceles, which means what? Yeah, the two sides and the base angles are the same. So two sides are the same, two base angles are the same. So we know that the double line angle is 38, so this double line angle is also 38. How are we going to find the base angles? 180 minus 38 is what? 142. 142 divided by 2 is 71. Okay. Now, can somebody tell me why I am not changing these to just show, oh, they're the same? Why am I leaving it as 1 marking and 3 markings? Yeah, because they're still, in the congruency statement, the order still matters. So I'm using these markings to help me show that the order matters, not necessarily just to say, oh, this is the same as this one and this is the same as this one. Does that make sense? I know that they're the same measurement. I'm about to show, oh, they're both 71, but the order of the congruency statement still matters, okay? So 71, 71, 71, 71, okay? So it's an isosceles triangle, so the base angles are all the same, okay? All right, what are the lengths of all of the sides? Well, the base is 18. Let's label the base. 18, 18. And then what about the sides of the isosceles? 27. 27. 27. 27. Okay. We are ready to fill things out. All right. The length of GJ is 18. XY is 27. ZY is 27. Measure of angle H is 38 degrees. Is everyone putting their little bubble for degrees? Okay. Measure of angle Z is 71. Because we know mathematicians, right? They want that bubble there. You don't put that bubble, they're like, where's my bubble? I don't know the units of measurement on that. Where's my bubble? Do you guys know why it matters? Not inches. There's another way to measure angles. Does anyone know what the other way to measure angles is? It starts with an R. So you're right. You're thinking degrees versus Celsius. I feel ya. I was there. I was there with ya. Anyone know what the other way to measure angles is though? It starts with an R. Radians. So in this context, I like that. I like that. That's good. In this context, we probably wouldn't measure in radians, but here's the difference. With a degree, you put the bubble. With a radian, you put nothing. So if you have nothing, a mathematician is going to play devil's advocate, because if there's nothing that mathematicians don't like to do, it's be pretentious. They're going to play devil's advocate, and they're going to be like, there's nothing there. It's a radian measurement. That's a very large radian measurement, because degrees typically go from like 0 to 360. Radians go from 0 to 6. So if you said that your radian measurement was 71, they'd be like, wow, that's a very big angle. Okay, so we always put the bubble there because math people can be silly sometimes. All right, measure of angle J is 71. All right. This next one?
Yeah.
Wait, have you drawn your markings yet?
I was going, but then I was like, okay, what order? I see alphabetical.
No. You know the order. The order's written. So draw your markings. So U, T, V, S, W, R. Okay. The X, Y, and Z are the variables you're solving for. Okay. So let's see what corresponds to what. So for X, we've got 1 to 2. So I got 12x minus 7 is 1 to 2 for the first one. So I'm going to look at 1 to 2 for the other one equals 53. On this one, honestly, we could probably use the ACE's method of just drawing a marking for the sides. So if you want to draw a marking for the sides, you can for this one. I am very consistent with how I do things. I don't like to have multiple different methods if I can avoid it. So I'm going to stick with this method if you guys are okay with that. Or would you guys rather draw markings on the sides too? What do you guys think? You're good doing it this way? Yeah? Anybody else have an opinion? Nope, you're good? Okay. 12x minus 7, what should we do? Add the 7. If anybody would like to do the method of putting markings on the side, you are absolutely welcome. I will not have any sort of feeling one way or the other. Okay, that's totally fine. All right, 12x equals 60. Oh, where's my x? And then what should I do? There's a little itty bitty x there, I just didn't leave space. Divide by 12. X equals 5. Okay, we got that one done. We got our z right here, 3z plus 14. This is the 1 to 3 side, so I'm going to look at the 1 to 3 side of the other one. That one's 50. So what should I do first there? I like how you said that like you discovered treasure. Ooh, a calculator. So we're going to minus the 14. We get 3z equals... I like how you guys are ignoring me because you're doing the problem. That's fine. Keep going. I like your lackluster explanation. You're like, Miss Rice, keep up with us. We're already past that. You guys, you're like, okay, this is easy. Let's move on. So 5y minus 33 is the 2 to 3 side. The 2 to 3 side is 57. This is fine. If I was you guys, I'd be asleep already. Or staring at the ceiling, twiddling my thumbs. That's what I did in math class. So 5y equals 90. Am I doing this right? Somebody help me. Thank you. Okay. So PHS. I used to teach at a PHS. It was Prairie High School. It was in Washington State. And okay. How far are you guys?
8, 9.
You guys! It's very rude that you're not waiting for me. Here, Seth. You're taking notes.
I'm alive.
Wait, Seth, is it excused or unexcused?
It was. Yeah, I wasn't out. Coincidence.
Okay. I just have to know so I can plug it in right. Okay. All right. So we've got 4z minus 32. Are you guys doing okay on 8? Should I just skip to the next one? What should I do? What do you guys want me to do?
I'm just go to 8.
Just go to 8?
Give us time to do all the problems and give us the answers after like 7 minutes, and then we'll go.
I just need direction on it.
Do you guys just want me to? Okay, here. We got this. Whew. How do we find angle S?
You have to do 180 minus 151 equals 29, and then 3y minus 1 equals 29, and then 3y equals 30, and then y equals 10.
That was too much for my brain. Okay, so here's what I would do. So this is 36, right? So this is 36. Would you guys agree? Okay, one marking, one marking. Okay, 2 markings is 115. So 2 markings is 115. Would you guys agree? So we have 2 of the angles in each of the triangles. How could we find the third one? Okay. Okay. The perimeter of a triangle, it depends on how long the sides are.
It's 18 and 23.
So you learn it in pre-calc. So like Asa said, if it's got a right angle, it's the Pythagorean theorem. But if it doesn't have a right angle, you do what's called the law of sines or law of cosines, which you guys don't learn until pre-calc. So you're going to have to wait for me for a second until we get to 8. Okay, what's the missing angle? 29. So this is 29, and this is 29. Okay, which means that our third equation over here is going to equal 29. I don't need to do any of that math now that we got the 29? We're good on 7? Okay. All right, so here's how I do problems like number 8. I do not like it when they draw the triangle shapes differently. Did you guys notice that? They draw them differently, and it's like it messes with you. So I always draw mine looking like an equilateral. Miss Rice, why? Because I'm not creative with my drawings. So I don't worry about them being drawn to scale. I also draw them so the orientation is the same. So I've got D, E, F, J, K, L. I do that because it simplifies how I do the problems. Does that make sense? So they said DE is 18. So I'm going to label that's 18. EF is 23. DF is 9x minus 23. Then they said JL is 7x minus 11. JK is 3y minus 21. Okay. Now, because I oriented these the same when I drew them, I almost don't even need the markings, the 1, 2, and 3 markings. But I went ahead and marked them anyway. So the 18 and the 3y minus 21 are marked the same. And so I can just say 18 equals 3y minus 21. And then the 9x minus 23 and the 7x minus 11 are marked the same. So the ones where you can draw your own picture and they tell you how to label it are almost better because you can make your picture more clear than the ones where they draw the picture for you. No. Nope, they just want X and Y. So 9, I'm going to do the same thing. Just to prove my point on this one, I'm not going to label the 1, 2, and 3. I'm just going to orient them the same. Do you guys understand what I mean when I say orient them the same? So I did Q, R, S, M, and P. So I labeled my triangles in the same order. So I know that Q and M are in the same spot. I know that R and N are in the same spot. I know that S and P are in the same spot. I did that on purpose so that my triangles look similar. So QR is 11, QS is 15, MP is 2x plus 1, angle S is 84, angle R is 32, angle M is 17y minus 4. All right. Can you guys help me find angle Q?
Wait, I'm not there yet.
32 plus 84.
110. Oh, this is hurting my brain. 110 and 6. 180 minus 110 is 70. Minus 6. 64. That was too much math. Ugh, gross. Okay, so we got 17y minus 4 is 64. And 2x plus 1 is 15. Okay. So I do want you guys to finish the notes of just solving these equations. When you draw your own picture, you can label the picture like this if you want, or you can just orient them the same and know that they are in the same spot. Whichever way is easiest for you is fine. Seth, I did take a video for you. Okay? All right. How are you guys feeling about this? Good? Marvelous.